We have a really interesting session this morning. We thought we'd talk about some of the things that folks are doing in the new technology area. So first up, we have Andy Nanneman. He's got 11 years of engineering experience and worked in bridge design at Arkansas DOT and 3.5 years and 6 years in heavy bridge maintenance. His roles in bridge and tunnel inspection, NIBUS management and support, asset management, maintenance, and rehabilitation. Andy received a degree in civil engineering from the University of Arkansas Fayetteville and is a professional engineer in Arkansas. And it's a tag team, so he's going to tag out at some point and hand it off to Kevin Weston. And Kevin Weston's been at Arkansas since 2019 in heavy bridge maintenance. So he's specialized in adding technology to everyday bridge inspection and management, so it's going to be great to hear from him. He also obtained a civil engineering degree from the University of Arkansas at Fayetteville, and he is a proud Arkansas native from Benton, Arkansas. So come on up.
Good morning, everyone. We're going to talk about bridging the gap with technology. First, heavy bridge maintenance. What do? We manage the bridge inspection program for Arkansas. We do almost primarily all of our inspections with state forces, and to do that we have multiple teams in each district, and we have 4 statewide teams centralized. They kind of supplement the districts, and they also kind of do the QA, QC. The heavy bridge maintenance engineers give them direction and kind of write the manual and policies. We also manage 6 bridge maintenance crews, which comprised of 3 maintenance crews, repair crews that could do anything from deck work, joint work, T-beams, or T-splices. They might even do major repairs on bridge strikes, such as rebuilding a column and cap. We have 1 bridge culvert building crew that's just getting started. We've ordered materials, we've done some hydraulic analysis, but have not really built our first structure yet. And we have 2 preservation crews, a painting crew and an overlay crew. We also, with all the bridge data from the inspection program, we help with asset management through modeling deterioration and giving recommendations. Now I'm going to let Kevin take over to talk about the technology and inspection side.
Thanks, Andy. So we're first going to talk about technology. In bridge inspection, we're going to go to the technology we use in bridge maintenance, and then finish up talking about the technology we've been using in bridge management. So to start off with technology and bridge inspection, everybody likes talking about drones, so I'm going to talk about what we're doing with drones. I got up here, wait, see if I got this. So we'll talk about our timber pile resistance micro drill a little bit, talk about the tablets we use in inspection, and talk about our new multi-beam sonar. First off, our timber pile micro drill. I'm sure y'all have seen these or heard of them, maybe seen a presentation over one of them. So we do have a timber pile micro drill, and we've begun to use more and more, and we're kind of in the process of doing our own little experiment testing, collecting some data, and then getting those piles that we're collecting data on and crushing those. So doing compressive strength tests to kind of get an idea of what you might receive on a graph, on one of these charts. So the micro drill is spinning, and it has a tip on it, so it's reading off the tip resistance at the same time as it's reading off so the rotational resistance. So you get 2 graphs. So right now we're in the process of comparing what we get from that information to a compressive strength test. And you can see right here, that's what it looks like, and this is the graph that you get the printout. So the drone use at ARDOT. And so I got a quote up here. You can ask me about it later. From 0 to 105 in 18 months. You can come and ask me about that. But so we primarily use this for aiding in visual inspections, getting high resolution pictures, videos of hard to reach areas. I'm going to go more into detail about that. We use for our high mass lighting pole inspections. And then we experimented with, tried out a few times using the IR, which is the thermal imagery for looking at delaminations. Y'all have seen presentations on that. And then also using the RGB images, creating an ortho image, and then doing crack detection on a bridge deck as well. So more about the drone use at ARDOT. You can see here we have 16 pilots. This has been a pretty big initiative for us lately. So we currently have 16 bridge inspectors, engineers, or assistant bridge inspectors that are a licensed Part 107 pilot. So that's just what we've designated in-house to be, I guess, a drone operator. You need to be the Part 107 pilot, following all the FAA rules. And you can see all 16 of these guys have their Part 107 license, and we also have 13 drones now in Arkansas. So I want to point out this, after talking to my contacts at the different drone companies, DJI, Skydio, Arkansas now has the most pilots and most drones in a bridge inspection program. And so there's DOTs, y'all might be a DOT that has like an aviation office. ARDOT does not have an aviation office. We're doing this all within the bridge inspection program. So a bridge inspector will have a drone in their truck. If they need it for a specific part or to get a better picture of something, they have that tool now available to them. So that's been huge for us. Some of the specialty work we can do with drones, and y'all have seen presentations, I'm sure, about using thermal imaging to look for delaminated concrete, look for hot spots pretty much. There's a lot of unsureties, I guess, about this technique, and you got to have the right day, the right time, no shadows, blah, blah, blah. The list goes on and on. But you can get a pretty good sense of quantity and location of delams using a thermal camera. And same thing right here. You see this? This is using some AI and ortho imaging, so pretty much taking images, combining one large image, in that having AI locate and size cracks. And so we have that capability, and we've used that a few times. Moving on from drones, we have our multi-beam sonar and LiDAR. And I'm sure y'all heard from Josh Mode on Tuesday and enjoyed his presentation over using a multi-beam sonar. And so we exclusively use the multi-beam sonar for channel inspections, looking at the underside elements of a bridge. And I'm going to go more into detail on that. But it gives you a better data to determine bridge foundation stability during flood events. So that's what stimulated this. Was the 2019, there was a record, I don't know if it was a 500-year or 1,000-year flood event on the Arkansas River. If we had this at the time, we would have been able to check in real time, scour, local scour and live bed scour on the Arkansas River. So now we do have that capability, and that's going to be great for flood events in the future. And then also for future use, we're looking to better determine a scour analysis and hydraulic modeling using this information, creating surfaces, running it through different programs. I'll show y'all more at the end how we're using the data, but you can see here two pretty pictures. This is in St. Charles, I believe, over the White River. You can see this local scour. So using this multi-beam sonar, you can easily pick up your local scour and be able to measure off of that and do volumes. I mean, you pretty much do whatever you want after you get a point cloud and have it as a surface. And you can also see right here, I'll show this in more detail. There's a pier cell near a pedestrian bridge in Little Rock that had tipped over that we used it to collect some data on. We also, all of our inspectors use iPads. So we try to limit the paper usage. We're going and using more and more apps on iPads. And so our inspection software is iPad based, and we also have it where it's offline. So that prevents us from having to have an internet connection. So that's helpful for our inspectors. And then some of the other things we use in inspection is the ultrasonic testing, a laser distance meter, a borescope, or an endoscope, and a rebar finder. So these are just some of the extra tools we use. If you're curious what the difference between a borescope, endoscopes are used in the medical field, but we found that they are actually better and higher quality than a borescope, and quite a bit cheaper. So we go with a borescope. So I'll hand it back over to Andy.
Yeah, I'm going to talk a little bit about technology we use in the maintenance side. I just got a few slides on each of these topics here. We'll start with our crack arrestor. I'm sure most of you are familiar with a crack arrestor. A crack arrest hole where you got a crack that's propagating, you drill a hole, and hopefully that stops the propagation. The idea here is you put a bushing in there, you expand it with a mandrel, and it puts compressive stresses around that hole, and research shows it's more effective at preventing the propagation of the cracks. We've used it on 300 different cracks, and none of them have been propagated yet. And as you guys know, Stuart, you can guess at why there's no audio to this clip, but there he is. He's reaming out the hole, and he's going to show you what the bushing looks like. There it is. He's getting the bushing, and then he's going to put the mandrel in there. And after that, you just expand the bushing and it puts compression around that hole, which would, it gives you a little more tolerance about where you put the crack arrest hole. There it is, expanding the bushing. And like I've said, I think it has a history in the air on airplanes, but it's really new that we're using, and they've worked well so far. Talk about heat straightening. There was a pretty good presentation on that yesterday, so I won't go into details there. We've recently started using a thermometer to give us a little bit more information about the temperature of the steel. We always called heat straightening more of a art or a craft and a science. Our guys have been doing it for decades and kind of pass it down. Our repair crews do about 7 to 10 jobs a year, and that way we kind of keep the knowledge, and this just gives the supervisor a little bit of more information while he's doing the heat straightening, to kind of monitor how it's working and just use that info to enhance his craft. The next thing we're going to talk about is going paperless, kind of like the inspection side. Just using apps on the phone or tablets or laptops, it just saves time and eliminates human error if people can just fill out an app with drop downs, and then whoever needs that information for filing and administrative purposes goes to the same site. You don't have to rely on someone to get the information, give it to a supervisor, them to get their laptop out, send an email. Hopefully that email gets picked up. It streamlines it. We also use an app for planning now. That way you don't need to print off a schedule or send a PDF of a schedule and try to keep track of that. You just go to the link, you see what we're working on, and you can also set up automatic emails in that program to where, say we're going from District 5 to District 9, and the District 9 folks want an email about when we're coming. That Thursday before we make that move, it'll send out an automatic email letting them know. The last piece of technology I'll talk about is our line boring machine. We've got a lot of pennant hangers in the state, and after decades of service, they start freezing up, getting a little corrosion, getting a little scary to where, we need to go out there and do some work. It's easy enough to have a fabricator fabricate some oversized pins, get some hanger bars fabricated to match those oversized pins, but you still got to get the existing beam ready to accept those oversized pins. The line bore machine's great at giving us a high precision diameter hole that will accept the new pins. So you come in, setting it up, the hard part after you got it set up, just let it do its work. It cuts a nice high precision hole, and then you've got a brand new pennant hanger system that hopefully you won't have to address for the rest of the service life of the bridge. I think next we're going to move on to technology in the bridge management side.
Thanks, Andy. So in the bridge management side, I like to call that the office work. We're going to talk about the dashboards we have available, the GIS SQL tools that we've been using recently, the tablet and inspection software, and then some Power BI. So first off, dashboards, and I'll show this and bring up the link at the end. But dashboard, and I have it on the next slide, what our dashboard looks like, so I'm just going to go ahead and jump to that. If y'all haven't been to our website, that shows all the bridge information for Arkansas in real time. I should send out the link, but you can get to it pretty easily. All you got to do is search for ARDOT Bridge Dashboard, and this link is going to pop up. And so this is all the inspection data. It's reduced down to the interesting information, the inventory items, that your condition you're worried about, your postings, and then it's broken up by categories. You can look by city, by MPO, Metropolitan Planning Organization. You can look by owner, and so Arkansas now has this available. It's been available for about 2 years. If you didn't know about it and you want to come look at the bridge information in Arkansas, and you can even click on each of the points and get even further information. It'll give you a little picture of the bridge and give you its current condition based off of the last inspection. So this has been great. It's good to share the information to the public so they're aware of what's going on. And to do some of this, I guess part of the bridge management side is using GIS software. So I'm sure every consultant or DOT is familiar with might have a GIS person on staff And so we've been using this software to help in our bridge management side. So one thing you can easily do is program management, or if your program jobs give you job limits and you need to instantly find where all the bridges along a route is, all it is a couple clicks of a button, boom, there's all your bridges for planning purposes. It's an awesome tool. One thing I wish it was coming with the new MBI changes, but it's not. It might be coming in the future. Is you can see each of these bridges. Arkansas has already gone ahead and taken our GPS points, converted those to lines along Arnold. And so if you don't know what Arnold is, you can talk to me later. But it's pretty much the linear referencing system. So now we have the ability to run spatial queries if you're curious about where your bridges cross the USGS waterways in Arkansas. You can find that with a click of a button. So that's pretty handy. So some of the other tools that we use, we make use of Power BI. And if you don't know what Power BI is, you probably, if you're working for a DOT, you probably have Power BI and you might not know about it. A lot of the, if you use Microsoft at the DOT level, you might be paying for it, so you ask your IT about that. But what you can do with it is really powerful. You don't have to know SQL. You don't have to have these GIS capabilities. Power BI will do a lot of that for you. All you got to do is take your inventory data or your bridge data or any data you're working with. It doesn't have to be specific to bridges. You can plug it into this Microsoft application, and you can easily do some pretty cool stuff with it. Here I brought in all the MBI data in Arkansas, and then I brought in all the program management, so all the planning stuff, all the jobs that we have to replace bridges, all the jobs we have to hydro, all the jobs we have programmed for polymers. And here I have them just displayed on a map and a table, and then I have drop downs if I want to look at all the bridges that are planning to be replaced here in the next 6 months. I mean, it's a click of a button now, and then that'll pop up for you. You can export it to Excel and look at it. So really powerful tool. We also, you can throw all your element data in it, your defects. And so if I want to look for all CS2 cracking at, I don't know, 50% or more of all the decks, then we have a Power BI setup, so you can put those inputs in, and it's going to give you all those bridges in Arkansas. So super powerful. You can join multiple data sets, you can drill into data, and you can provide powerful insights. So that really awesome tool. With that, we're going to open it up to questions, and I actually have my own question to begin with. Somebody should ask me, well, what are you doing with all that sonar data, all those point clouds? So I'm going to answer that. The answer to that question is using Arcgis. One of the things I talked about in the bridge management section was making use of GIS tools, and so that's one of the things we're making use of. We're putting each of these data sets, and you can imagine it's quite large data files. So we take the exports from the data we collect. We collect the sonar, which is the bathymetry that Josh was talking about. We collect the LiDAR, which is the top side, makes the pretty picture. And this is all survey grade, like I said, and we put this into ArcGIS, which is a GIS application, and publish it online. Now, it's not public, so you can't go to this website and see it. It's just for internal only. But that's why I wanted to talk about it and show it. These go all into a web application where you can easily navigate, and depending on your internet connection, that's what's your limiting factor, is how many points we'll display is based off of how fast your internet is, which if you're in an office setting is probably faster than it is showing right now. Once more points load, you can easily see areas around foundations, what your elevations are, different things that are going on in the I guess sub-water line, and you can there's different things you can do with this. You can measure from any point to any point and easily get a measurement off that. You can click on these on any point, and it's giving you an elevation, and so all these elevations are in meters just because that's how the web works, and it's to Arkansas State Plain north or south. And so you can easily just take what your elevations are in here, compare them to the plans that the bridge was built. You can see if you're getting into scour related issues. And I want to show just a couple pretty pictures because everybody likes pictures. And you can see all the ones we've already done here on the right hand side, quite a big list. I was mentioning that pedestrian bridge earlier, waiting for the points to load. But here you go. You got a pier cell that was scoured out. And this is a pedestrian bridge. This is not a highway structure, but you have major scour hole, and then we also had a barge that hit it, so you got two things. Get there, and this, if you know how to work Google Maps, this is going to be fairly straightforward and easy. All it is a web application like Google Maps, like a 3D Google Maps, and so we have this available for our bridge inspectors in-house.
How are you capturing these points?
Yeah, so we're capturing these points. I don't have a picture of the boat, but if y'all saw Josh's presentation on the multi-beam sonar and LiDAR system, we have one of those. We have one of those systems now as of I think July, August, and so we pretty much attached that portus pole and sonar system to a side of either our flat bottom or the survey's boat, and we're working on another boat. So you can attach it to any of those. Just go out there and set it up, survey all day, I guess. And I'll add to that what somebody asked the question to Josh about how do you have to have a base station or what are you using? Most of the time, I'd say 99% of the time, we don't use a base station because we're using a hotspot if we have internet with our ARDOT cores network, which is the N-trip. It gives real-time corrections, so everything's survey grade according to those corrections.
Not a technical question. I just wanted to know what pedestrian bridge that was.
Oh, yeah. Sure. That's, if anybody's familiar with the Clinton Library in Little Rock, that is the Clinton Library pedestrian bridge. And that was about a month ago. So we just, I guess, a good partnership with the city of Little Rock, we offered to go do this for them, collect that data so they could actually see, if there's rock still in it, if it's crushed underneath. So that's why we went to do that. And surprisingly, it is still full of rock. Got a question. Does surveys do this, or are we doing this with, within heavy bridge? And so we're doing this within our heavy bridge maintenance section. So we got a crew that's been rolling around the clock doing these.
The preceding was produced by the National Center for Pavement Preservation. More information can be found on the web at pavementpreservation.org. Additional support provided by Michigan State University.